Alright, so today we're going to look at a few topics that we learned the past 2 weeks. So we're going to look at similarity statements, setting up and solving proportions, indirect measurements used to find missing sides, and then we're going to use the geometric mean to find missing sides of 3 similar right triangles. Alright, so the first thing we want to do is write a triangle similarity statement. So you don't always have to do this, but you can if you want to. So if we want to write a triangle similarity statement, what we want to do is separate the triangles. So here this shouldn't actually be too bad. All right, whoops. So I'm going to separate the smaller triangle from the larger triangle. All right. So here, notice that angle A is shared between the 2 triangles. And then we know that here, these 2 angles, and let's just assume that DE, all right, is a mid-segment. It actually doesn't have to be a mid-segment, but let's just assume it's a mid-segment. So because it's a mid-segment, that means DE and CB are going to be parallel to each other. That means we have corresponding angles that are going to be congruent. All right, so once you've labeled your angles, and actually let me mark this here. Now you can set up your similarity statement. So triangle ADE, and remember order matters, is similar to triangle. So here we have ADE, so make sure your corresponding congruent angles also match up. So we have ADE, that would match up with ACB. Right. So this would be your triangle similarity statement. Right. So you just want to make sure that your vertices, they match up. So A obviously matches up with A, D matches up with C, and then E matches up with B, and that's what we have here. Right. And then for the second problem, we're going to solve proportions by setting up similar triangles. All right. So here, it looks like these 2 triangles aren't similar. We're going to assume that they're similar, and sometimes it might help if you just redraw them in the same orientation. So what I'm going to do is I'm going to take this smaller triangle and redraw it in the same orientation as this larger triangle. All right. So here this is going to be E, F, and then D. So here, 21, that's going to be the side length of FE, and then DE is going to be 30. So here I would just simply match up the corresponding sides to solve for X. So my goal is to solve for X. So my proportion, and you could write up a number of different proportions, but typically what I like to do is I like to pick one side of a triangle and then match it with the other side of another triangle. So corresponding sides, you want to make sure that they're in the same ratio. So 21 over 77, all right, equals 30 over 11x plus 11. And then here you could just simply cross multiply. All right, so 21, we have 21 times 11x plus 11 equals 30 times 77, which is 2310. All right. Now here I can distribute the 21, but I'm going to do something that most of you should be familiar with. I'm going to divide by 21. That's actually going to save me an extra step in the calculations. So I have 11x plus 11 equals 110. And then this becomes a two-step equation. I subtract 11. So 11x equals 99. And then I divide by 11 on both sides. I get x equals 9. And then for the third problem, so here we're going to use indirect measurement to find a missing side. So during peak hours of the day in the summer, peak vitamin D production occurs when the shadow is 1/4 the length of the object. So suppose that John stands in a shadow of a flagpole so that he is 3/4 away from the base of the flagpole, but also his height perfectly aligns with the rays of the sun casting a shadow such that the end of his shadow aligns perfectly with the end of the pole's shadow. So if the pole's shadow is 8 feet long during peak hours, find the height of John. So what we want to do is we want to draw our picture. Right? So here's the flagpole. We don't know what the height of the flagpole is, at least not yet. And we know that the shadow, and again, this is not drawn to scale, so please don't look at this as being drawn to scale. So we know the length of the shadow is going to be 8 feet tall. Right? So John stands in a shadow of a flagpole so that he is 3/4 away from the base of the pole. So basically he's standing 3/4 away, the length of the shadow, away from the base of the pole. So here, this is where John is going to be standing. And here, let's say that this side length right here, that's going to represent basically the sun's rays. All right. So the sun's rays that cast a shadow on this flagpole. And let's say John, according to the problem, right, his height is perfectly aligned, right, with the sun's rays, so that his shadow is also perfectly aligned with the end of the flagpole shadow. Right. So here we really have two triangles. Right. And this is going to be a right triangle. And what you can do is you can separate the two triangles. So you have the triangle made by John here, and then you have this overall larger triangle. So here John, remember, stands 3/4 the length of the shadow away from the base of the pole. So we want to know, well, what is 3/4 of 8, right? So 3/4 of 8 is going to be 6, right? That's 3/4 times 8, that's going to be 6. So from the base of the pole to basically where John is standing, that's going to be 6 feet. So that means this right here is going to be 2 feet. So let's draw two separate triangles. Right. So here we have the larger triangle, right, and then we have the smaller triangle, right, and we want to find, the height of John. We'll call this Y. Right. So John's shadow is basically 2 feet tall in this particular case, right? So we know that during peak hours, the shadow is going to be 1/4 the length of, whatever object is casting a shadow. So 1/8 is 1/4 of what number? So what that means is that x times 1/4 equals 8. And here, to get rid of this fraction 1/4, I'm going to multiply by 4. So I know the flagpole is going to be 32 feet. All right, so it's going to be 32 feet. So I want to find John's height. So here I could just basically use a proportion. I'm going to set up my two ratios. So 32 equals, whoops. So 32 corresponds with y, right? And then 8 corresponds with 2. So here we just multiply. So 32 times 2 equals 8 times y. And here we have 64 equals 8. And then divided by 8. We get 8. So, yes, I do realize that John is incredibly tall. So John is incredibly tall at 8 feet tall. But regardless, as long as your math holds up, you should be fine. Right? And then the last problem. Right? So here, what we want to do is we want to find the 3 missing sides right here of this triangle. Right? And you'll notice the diagram right here, especially if you had me. I'm not sure how your teacher taught it, but the way I taught my students was I gave them the formulas for the geometric mean. And you can get these formulas real easily if you just separate, these 3 triangles, redraw them in the same orientation like you did in the homework, and then just set up your ratios and proportions. Right? So here, I want to find the missing side. So I know I have 8 and I have 2. So I'm going to match the diagram right here. I'm going to call this side V. I'm going to call this side Z, right? And I'm going to call this side W. So I want to find AC, which is V, CD, which is Z, CB, which is W, right? And the first thing I want to find is here, and let me switch colors, right? So I want to find Z, right? So here, the only measurements that I have is 8 and 2. And that corresponds with X and Y down here, right? So I have X, and then I have Y, and I'm trying to find Z. So I want to look, well, which one of these ratios is going to help me? Well, this first ratio right here that has X, Y, and Z. So X over Z, that's the same thing right here, 8 over Z. Right? Equals Z over Y. In this case, Y corresponds with 2, or Z over 2. And if I cross multiply, I get Z squared equals 16. And then simply take the square root. I get Z equals 4. Alright. So I have CD, right, equal to 4. And then let's say the next thing I want to find is going to be W. Right. So here, and actually let me mark this. Right. So here I want to find W. Right. I want to find this missing side. And if I take a look at the second proportion right here, right, this has W, so I need the measurements of U and Y. So U in this particular case is going to be 10. Right. And Y is going to be 2. Right. So just corresponding my triangles right here. So here I have U over W, and I'll call this U. So that's 10 over W, right, equals W over Y, or W over 2. And then cross multiply, I get W squared equals 20. And then whatever the square root of 20 is, All right, that's going to be 4 point something.